Hi students, how are you today? Welcome you to Top Tutors, where you will get toppers e-learning classes. Understand every single concept and be a topper. That is our motto. Today we are discussing 10th grade Cbse mathematics, chapter number 1, real numbers. In the chapter, the topics proving the irrationality of numbers like root 2, root 3, root 5. These are the topics what we are going to discuss today. Before that, we can just revisit rational number, irrational numbers, and direct consequence theorem of fundamental theorem of arithmetics. Okay, fine. Rational number. A number is called a rational number if it can be written in the form of p by q, where p and q are integers and q not equal to 0. That we have learned already, right? Any number we can write as a numerator and denominator, but the numerator and denominator should be integer. Integer means 0, 1, 2, 3 to the right side and the left, -1, -2, -3. Such numbers, that set is known as integers. So numerator and denominator should be integer. But there is a condition is there. The denominator cannot be 0. What is the reason? Division by 0 is not defined. Okay. So set of natural number, integers, all coming under rational number. What is irrational number? A real number which is not rational number is irrational number. By definition, a number is called an irrational number if it cannot be written in the form p by q, where p and q are integers and q not equal to 0. Normally, rational number we are denoting by capital Q, and irrational number we can denote it by q dash. Q dash. For example, root 2, root 3, root 5, etc. are coming under irrational number. So any prime number, its root is coming irrational number. Similarly, pi is irrational number. Normally we will take pi, the value of pi as 22 by 7, right? 22 by 7. Or we will take the decimal value as 3.14. So decimal, the fractional form 22 by 7, here the numerator 22 is an integer, denominator 7 is an integer, and 7 is not equal to 0. So it is actually in the form of p by q, where p and q are integers and q not equal to 0. So it has to be considered as a rational number. Then why we are not considering? Similarly, 3.14, decimal expansion of rational number is either in the form of terminating or non-terminating recurring. Non-repeating, but non-ending by repeating. So that way also 3.14 has to be considered as a rational number. But actually, these are all approximate values, not exact value. So exact values are non-terminating, non-recurring. So pi is considered as irrational number. E is irrational number. Similarly, 0.10, 110, 1110, 11110, non-repeating, non-terminating, non-terminating, non-recurring. So all these are coming under irrational number. Okay. Fine. If you add, subtract, multiply, or divide a rational number and irrational number, the result will be an irrational number. The sum, difference, product, or quotient of a rational and irrational number is also an irrational number. Okay, suppose you are adding rational number. The notation of rational number we have taken as q, right? So capital Q plus q dash. Q dash is irrational number. The product also will be a irrational number. Similarly, if you subtract rational number and irrational number, the result will be irrational number. If you multiply rational number multiply by irrational number, the result will be irrational number. Similarly, rational number divided by irrational number, then we are getting irrational number. So that is we are saying here, the sum, difference, product or quotient of rational and irrational number is also an irrational number. Okay. Now, direct consequence theorem of the fundamental theorem of arithmetics. In the textbook, it is given as theorem number 1.3. Okay, what is the theorem saying? Let P be a prime number and A be a positive number. If P divides A square, then P divides A. This theorem is known as direct consequence theorem of the fundamental theorem of arithmetics. What is it? Let P be a prime number. You know prime number, right? A number which has only two factors, which are the 1 and that number itself. Such number are known as prime numbers. The number which are not prime numbers are known as composite number. Composite number has more than two, minimum more than, it should have more than two factors. Okay. So let us see here the theorem saying, if P divides A square, then P divides A. I have 12 square. 12 square means what? 144. Okay. I have a rational number 3. So 3 divides 144 means 12 square. What is the reason? Divisibility rule. You can if you have doubts on divisibility rule, you can watch my divisibility rule video. So 3 divides 12 square. 12 square means 144. How will you check the divisibility? 1 plus 4 plus 4. Add all the digits. If it is divisible by 3, the number is divisible by 3. So 1 plus 4 is 5. 5 plus 4 is 9. So 9 is a multiple of 3. So no, 9 is divisible by 3. So 144 is divisible by 3. It means we can say that D3 divides 12 square. So the theorem saying 3 divides 12 also. This simple theorem is known as direct consequent theorem of the fundamental theorem of arithmetics. Fine. So if you have a prime number, that prime number divides a square number, then that prime number divides its square root also. P divides A square, then P divides A. Okay, simple. But this theorem we can use to prove the irrationality of the number, root 2, root 3, root 5, etc. You want to prove they are irrational, 3 root 2. We will use this theorem. Now let us recap. Co-prime integers. Two integers A and B are said to be co-prime if the only positive integer that evenly divides both of them is 1. So their highest common factor is 1, HCF. If you take example, we can take, let us see, 10 and 15. What are the factors? 10 has factors 1, then 2, then 5, also 10. 15, what are the factors? 15, 1, 2 is not there, 3, then 5, 15. So other than 1, they have a common factor 5. Other than 1, they have a common factor 5. So 10 and 15 are not coprimes, not coprimes. When we are talking about coprimes, we are comparing two numbers relatively a prime. Okay, not like prime numbers. Prime numbers we are discussing, we are taking only one number and checking whether it has only two factors or more than two factors. But when you're saying coprime, you have to take two numbers. We are comparing two numbers. If their common factor is only 1, then that two numbers are called coprime integers. Okay, let us take another example. 3 and 5. Here 3 and 5, they have the factors of 3 are 1 and 3. Factors of 5 is 1 and 5. So common factor is only 1. So 3 and 5 are coprime. 2 and 3, factors of 2 are 1 and 2. 3 is 1 and 3. Common factor is only 1. So 2 and 3 are coprime. 14 and 15. 14's prime number, their factors are what? 1, 2, then 7, 14, right, etc. 15, we have 1, 3, 5, 15. So what is the common factor here? In 14 and 1, common factor is only 1. So we can say 14 and 15 are co-prime. They have common factor only 1. Such numbers are known as co-prime integers. Co-prime integers. This term also we will use to prove the irrationality of numbers. Clear? Okay. Now, prove that root 2 is irrational. We have to prove that root 2 is irrational. This question is a sure question for board exam, Cbse board exam 10th grade. Okay. Root 2, root 3, root 5, one of them they will ask every year. Okay. So we will discuss this in details. Actually, we are proving root 2 is irrational by the method of contradiction, proof by contradiction. What by proof by contradiction? We know root 2 is irrational number. So we'll assume the opposite of that. We will assume that root 2 is irrational. And we will do step-by-step procedure. And we will get a wrong statement. That statement will be contradict with our initial assumption. Then we will argue that this is due to our contradiction. So root 2 is irrational. This method is known as proof by contradiction or contradiction method. Okay, so let us start. So we have to assume that the root 2 is rational. If root 2 is rational, if root 2 is rational, then just now we have learned the definition of root 2, rational number. It is in the form of p by q, where p and q are integers and q not equal to 0. So this root 2 we can make it as p by q, where p and q are integers and q not equal to 0. But here this p and q, numerator and denominator, we will write in their simplest form, where they have highest common factor as only 1. P and q have only 1 as the common factor. So such case we can call these as co-prime. So here we can say P and Q are co-prime, first part. Then we will square on both sides. If you square on both sides, what will happen? You will get 2 equal to p by q. P square by q square. We are squaring on both sides. Now take q square to this side. So we'll get 2q square equal to p square. 2q square equal to p square. So 2 times q square, 2 into q square, right? Suppose we have 3 into 2 equal to 6. We can say 3 is a factor of 6, 2 is a factor of 6. It means 6 is divisible by 3, 2 is divisible by 6. Or we can say 2 divides 6 or 3 divides 6. Same logic we can use here. 2 times q square, 2 into q square means 2 is a factor of p square. It means 2 divides p square. P square is divisible by 2. Okay, so we can say that 2 divides p square. Or we can say 2 is a factor of p square also. So as per our theorem what we have learned, we can also say that 2 divides p, right? A prime number, if divides its square, then it will divide the square root also. If 2 divides p means 2 multiply by some integer will give you p. So we can consider 2 multiplied by m gives you p. So if you square on both sides, what will happen? 2m whole square means 4m square equal to p square. Correct? Because this 2 multiplied by some integer will give you p. So 2 square into m square, 4m square equal to p square. Okay. Now we have a p square here also, the starting. See, here we have a p square. Now here also we have a p square. Now what we are going to do is, since the RHS are equal, we can equate the LHS. If you equate the LHS, we will get that 2q square equal to 4m square. Now we will divide both sides by 2. So we will get q square equal to 4 by 2 is 2. 2 by 2 is 1, that is q square. 4 by 2 is 2m square will get. Now q square equal to 2m square means what? 2 times m square. 2 into m square is q square. It means 2 is a factor of q square. M square is also a factor of q square. It means 2 divides q square. M square also divides q square. Or q square is divisible by 2. Q square is divisible by m square. All these we can say. But what we need is only 2 divides q square. So as per our theorem, direct consequence theorem or fundamental theorem of arithmetics, just we have discussed, we can say 2 divides q. 2 divides q square means it implies 2 divides q. See, now here 2 divides q. Here 2 divides p. It means what? We have starting. So in starting, we have considered that p and q are co-prime. Means they have highest common factor is 1. P and q are in the simplest form. It means they have only 1 as the common factor. That's why we call it as co-prime. Now we proved that. See, 2 divides p means 2 is a factor of p. 2 divides q means 2 is a factor of q. So other than 1, we have proved that 2 is a factor of, there is a common factor for p and q, which is 2. So this is a contradiction to our assumption that p and q are co-primes. Why it's happened? Because starting we have assumed that root 2 is rational. So root 2 is irrational. This is the way how we have to prove root 2 is irrational. Okay, now the same thing. Once again, we will discuss step by step. First, let us assume that root 2 is rational number. Root 2 is rational number. So when you're assuming root 2 is rational number, it is what? It is a contrary assumption. Contradictory statement or contrary assumption. That's the first step. Second step, what you have done? We have written, since it's a rational number, we assume that rational number, we can write root 2 equal to P by Q. We can write like this. Root 2 equal to P by Q, where P and Q are integers and Q not equal to 0. And also let P and Q are co-primes. We are assuming P and Q are co-prime. So by the definition of rational number, we are writing root 2 as P by Q, where P and Q are integers. And P by Q, we are taking the simplest form. We are dividing it by both numerator and denominator. We are cancelling all common factors and we are making it the simplest form. So we can call P and Q are co-primes. Okay, what is the next step we have done? We have taken the next step as 2 equal to P square by Q square. How we are getting this? By squaring on both sides. So root 2 square is 2. P and Q will get squares, P square and Q square. Now we will take Q square to the our LHS, left side. So what will get next step? We will get 2Q square equal to P square. From the statement 3, we will get that 2Q square equal to P square. We have just taken this Q square to LHS. Okay. Now, see, as we discussed, 2 times Q square equal to P square means 2 is a factor of P square. It means 2 divides P square. P square is divisible by 2. Different way we can say. So we can write that 2 divides P square, or 2 is a factor of P square. Both way we can say. Okay, use this one, 2 divides P square. Okay, both giving the same meaning. Next step, we can say 2 divides P. Direct consequence theorem of fundamental theorem of arithmetics. What it say? If P divides A square, then P divides A. So here 2 divides P square, then 2 divides P. Or we can say 2 is a factor of P also. What is the next step? Now, if 2 divides P, 2 multiplied by some integer has to give you P. It means 2 times M, 2M equal to P, where M is an integer. We know a dividend equal to what? Divisor into quotient plus remainder. Since it divides, divisibility, P is divisible by 2, then the remainder will be 0. So this remainder is not required. So divisor into quotient will give you dividend. So here our divisor is 2. So 2 multiplied by some integer as a whole number or integer we can say, we have to get the dividend. So this 2 divides P, always we can write it as 2 times some integer equal to P. Fine. Now we are squaring on both sides. So 2M whole square equal to P square. 2M whole square means 2 square into M square. 2 square is 4. 4M square equal to P square. Now, see some speciality. Here we have 4M square equal to P square. Here we have 2Q square equal to P square. What is the speciality? RHS, right hand side of these two equations are same, P square, P square. In such cases, we can say that their LHS are equal, means 2Q square equal to 4M square. So we can write 2Q square equals 4M square. This is from statement 4 and statement 8. Next, divide both sides by 2. So we'll get Q square equal to 2M square. We are dividing q square by 2, so we get q square. Then we are dividing 4m square by 2, we are getting 2m square. See, now we can say 2 divides q square. 2 divides q square. Why? Because 2 times m square means 2 is a factor of q square. M square is a factor of q square. It means 2 divides q square or m square divides q square. But what we need is 2 divides q square is enough for our proof. So we are writing 2 divides q square. That implies 2 divides q also. Direct consequent theorem of fundamental theorem of arithmetic, DCT of FTA. Short form. Now, see here in this statement we have 2 divides q, right? 2 divides q. Here we have 2 divides p, correct? 2 divides q, here 2 divides p. That is 2 divides p and 2 divides q. Therefore, 2 is a common factor of p and q from statement 6 and statement 11. Correct? 2 divides p and 2 divides q means 2 is a common factor of p and q. What is the meaning of that? We have considered p by q as co-prime. We have considered that they have common factor as only one. So this contradicts the assumption that p and q are co-primes. In the starting, we assume that they are co-prime. Therefore, root 2 is irrational. Therefore, root 2 is irrational. So we have proved. Clear? Methods are clear? Okay. So if you want, you can take a screenshot of the page, or you can write it. Let us go for the next proof. Prove that root 3 is irrational. Same way we can prove by contradiction. Same method we can do. Let us assume that root 3 is a rational number. Contrary assumption. So what we can do, we can use the definition of rational number. We can write root 3 equals p by q, where p and q are integers and q not equal to 0. Definition of a rational number. And also we have to make p and q into their simplest form. So we can say that p and q are co-primes. First, we assume that they are rational number. Secondly, we assume that they are p by q form p and q are co-primes. Third point, square on both sides. If you square on both sides, root 3 square will be 3. So 3 equal to p square by q square by squaring. Fourth, take the q square to the left side. So we'll get 3q square equal to p square. The third statement rearranged. Now, 3 divides p square, or 3 is a factor of p square, right? Because 3 into q square equal to p square means 3 is a factor of p square. It means 3 divides p square. Now what we can say? 3 divides p, right? 3 divides p, or 3 is a factor of p. That is a theorem. If p divides a square, then p divides a. Next, since 3 divides p, 3 multiplied by some integer will give you p. So 3 times m, 3 into m equals p, where m is an integer. Square on both sides. So 3m whole square equal to p square. 3m whole square means 3 square times m square. That is 9m square equal to p square. 9m square equal to p square. Now check. We have p square. We have two statements. One is 9m square equal to p square. Other one is 3q square equal to p square. Since RHS are equal, we can say LHS are equal. So we will write 3q square equal to 9m square in the next step. So 3q square equal to 9m square from statement 4, this statement 4, and this statement 8. Okay. Now what we have to do, divide both sides by 3. So if you divide both sides by 3q square by 3 will give you q square, 9m square by 3 will give you 3m square. Now 3 times m square gives you q square, means what? 3 is a factor, m square is a factor. It means q square is divisible by 3, q square is divisible by m square. It means 3 divides q square completely. M square divides q square completely. But what we need is 3 divides q square. That implies 3 divides q. Direct consequence theorem of fundamental theorem of arithmetics. Fine. Okay. Now what we have? We have 3 divides q. Here 3 divides p. 3 divides p and 3 divides q. What is the meaning of that one? 3 divides p and 3 divides q means what? 3 is a common factor of p and q from 6, this 6, and 11. 6 and 11. Now we can say that this contradicts the assumption that p and q are coprimes. We assume that p and q are coprimes. So now we got, other than 1, 3 is also a common factor of p and q. So this is a contradiction to our assumption. Therefore, root 3 is irrational. Root 3 is irrational. We have proved. Hence it is proved. Clear? Very easy. Fine. So if you want, you can take a screenshot or write it. Okay. Same way we will do one more problem. So we will be mastering. Prove that root 5 is irrational. Same contradiction method we are doing to prove this. First, what you have to do? We have to assume that root 5 is rational number. Contrary assumption. Then we have to write as per the definition of rational number. That is root 5 equal to p by q, where p and q are integers and q not equal to 0. P and q, bring them to their simplest form. That means p and q are coprimes. P and q are coprimes. Then third statement. Square on both sides. So we will get 5 equal to p square by q square. Root 5 square is 5. Here we are squaring p square by q square. Then we have to bring q square to the LHS. So 5q square equal to p square. 5q square equal to p square. Right? We have taken this q square to the LHS. Now 5 times q square equal to p square means 5 divides p square. 5 divides p square. Correct? So we can say 5 is a factor of p square also. The second part is no need for the writing for the examination. First is enough. If you are writing 5 divides p square, no need to write this one. If you are writing this one, no need this one. One of them is okay. So as per the theorem, we can say 5 divides p. 5 divides p. Okay. If p divides a square, then p divides a. Next statement is, since 5 divides p, 5 multiplied by some number will give you p, that we are taken as m. So m, 5 multiplies m, right? 5m equal to p. 5m equal to p. 5 times some integer equal to p, where m is an integer. Now we are squaring on both sides. So we'll get 5m whole square. 5m whole square equal to p square. So 5m whole square is 5 square into m square. 5 square times m square is 25m square equal to p square. Now see, here we will get, we have 25m square equal to p square. 25m square equal to p square. 25m square equal to p square. Correct? Here what we have, 5q square equal to p square. So we have RHS are equal. If RHS right hand sides are equal, left hand sides are also equal. So we can say that 5q square equal to 25m square. Okay, so that is the next step. Next step, we are writing 5q square equal to 25m square. This is from 4 and 8. 4 and 8. Now divide both sides by 5. If you divide both sides by 5, 5q square by 5 is q square, 25m square by 5 is 5m square. Now see, here q square equal to 5m square, right? So 5 times m square means what? Q square is divisible by 5, q square is divisible by m square. It means 5 is a factor of q square, m square is a factor of q square. It means 5 divides q square, m square divides q square. But what we need is 5 divides is enough. So we'll write 5 divides q square implies 5 divides q, direct consequent theorem of fundamental theorem of arithmetics. See, here we will get, we are getting two statements. Here we have 5 divides q. Here 5 divides p, right? So therefore 5 is a common factor. 5 is a common factor of p and q. 5 is a common factor of p and q. What is the meaning? Actually, this contradicts the assumption that p and q are coprimes. Starting, we have made p and q to their simplest form, and HCF was 1. Other than 1, there was no common factors. So we call them as coprimes. Now we got 5 is also a common factor for p and q. So this is a contradiction to our assumption that p and q are coprimes. Therefore, root 5 is irrational. Hence it is proved. Hence it is proved. Clear? Okay. Note it. Note it. One more problem we can do in this session. Okay. Fine. Prove that 3 root 2 is irrational. Here we are just approaching in a different way, because already the root 2 is irrational we proved. Okay. After proving, it is a well-known fact, root 2 is irrational. That fact we can use here. Fine. So we'll approach in a different way. Different way means starting is in same way only, that we will consider 3 root 2 is rational. Our assumption like that only. So first what we'll do, let us assume that 3 root 2 is a rational number. Contrary assumption. Contrary assumption. Okay, say contradictory statement, 3 root 2 is rational number. We are assuming. Now, since it is a rational number, we can write in the standard form. So 3 root 2 equal to p by q. 3 root 2 equal to p by q, where p and q are integers and q not equal to 0. And also let p and q are coprimes. Make them into simplest form. Okay. Now take this 3 to the right side. Take the 3 to the right side. What will happen? So you will get root 2 equal to p by q. Right? If you take 3 to the left side, you will get root 2 equal to p by 3q. Right? See, here p is an integer, q is an integer, right? P and q are integers, and 3 is also an integer. So an integer divided by 3 times an integer is also an integer, correct? So this right side is an integer. If right side is an integer, left side also should be an integer, correct? Okay. So we'll write that statement. P by 3q is a rational number, right? An integer by an integer. It is a rational form. So it is a rational number since 3a, b are all integers. So since RHS is an integer, LHS should be an integer, I mean the rational number. RHS as a rational number, LHS should be a rational number. Okay. So therefore root 2 is rational from 3 and 4. The statement 3 say that root 2 equal to p by 3q. Both are equal. So we prove that right side an integer by another integer where the denominator is not 0. So it is a rational number. If RHS is rational number, then LHS also should be a rational number. So according to that, we can say that root 2 is rational. Root 2 is rational. Okay. But we know that root 2 is a irrational number. There's a fact that we already proved. Okay. We proved that. So this contradicts the fact that root 2 is irrational. Therefore, 3 root 2 is irrational. 3 root 2 is irrational. Okay, clear? So learn it proper. One of the question will come sure for the board exam. We have done step by step. Okay, step by step with all statements as explanation in the square bracket. So very easy to understand and to do for the examination point of view also. Without any error, you can do it. So learn well, understand every single concept properly. Okay. If any doubt, you can ask by email or WhatsApp, and also in my online class, few registered students can ask the question there also. And also we will do the advanced problem there. Okay, all past papers, question asked from this, all the section. The last 10 years paper will be solved. Okay, fine. See you in the next class. Bye bye.